A massive wave of solar energy is slamming into our planet at this very moment, and the chain reaction it has started is unlike anything we expected. We are witnessing a celestial event of remarkable power, one that stretches the invisible bonds between our star and our world, revealing a tapestry of connection that modern science is only beginning to map. This isn't just a light show in the sky, it is a fundamental demonstration of force, a reminder that we inhabit a dynamic and interconnected system where actions on the sun have profound and sometimes unsettling echoes right here on the surface of our planet. We are now witnessing the arrival of a significant coronal mass ejection, a billion-ton cloud of magnetized plasma hurled into the void by the sun's immense fury. This differential image reveals the sheer scale of the blast now traveling toward Earth, a propagating shock front, visible against the backdrop of the solar corona. Current forecasts predict this event will spark a G3-level geomagnetic disturbance, a substantial storm in the vast theater of space weather. On a scale where G5 is the most extreme, a G3 is classified as a strong to severe storm, capable of influencing satellite operations, inducing currents in power grids, and of course, painting the heavens with breathtaking auroral displays. The source was a tremendous eruption on our sun's surface, a release of magnetic energy so vast it can temporarily outshine the sun's own photosphere in certain wavelengths. Observe this stunning dual-wave effect at the start of the sequence, a telltale signature in the coronagraph data. What you're seeing first is the initial shockwave from that solar detonation, a precursor of compressed solar wind racing ahead at incredible speed. Following close behind is the dense cloud of charged particles in its wake, the main payload of the coronal mass ejection. Both that leading edge and the main bulk of plasma are now on a direct path toward our world, a journey of approximately 93 million miles, undertaken in a mere matter of days. Their arrival is not a gentle touchdown, but a violent collision with Earth's protective magnetic bubble, our magnetosphere, which will shudder and compress under the assault. But here is where the plot thickens, dramatically. This powerful solar flare coincided almost perfectly with a major seismic event, a magnitude 7.0 earthquake that struck deep beneath the Alaskan peninsula. The sun's rage echoed in the Earth's shudder, a synchronous event across the cosmic void that immediately captures the imagination and challenges conventional understanding. Alaska was positioned on the daylight side, fully exposed to that initial burst of radiation and energetic particles from the flare. Since the main quake, the region has been rocked by over 150 aftershocks, a relentless cascade of subterranean adjustments that speaks to the massive energy transfer within the Earth's crust. We'll delve into that strange synchronicity, peeling back the layers of data and theory. We'll discuss when the solar storm peak is expected, breaking down the timeline for maximum geomagnetic activity, and we will map out where you might see the auroras, both in North America and Europe, providing a practical guide to witnessing this celestial consequence. Let's begin with the sun itself, the engine of this entire sequence. Two significant flares recently launched from an active sunspot group, a complex region of intense magnetic fields. The first, a powerful M-class eruption, was followed by an M1-class flare as a kind of potent encore, a clear signal that this active region was thermally and magnetically unstable. This tells us the active region is far from quiet. It is a simmering cauldron of potential. It continues to rotate toward a more Earth-facing position, leaving experts to watch the next 24 to 72 hours with heightened anticipation, knowing the sun's full arsenal may not yet be on display. Could this be the prelude to an even more active phase, a cycle of fury we haven't seen in recent years? The sun operates on an 11-year cycle of activity, and we are currently in a ramp-up phase toward a predicted maximum, suggesting such events may become more frequent and potent. Meanwhile, another enormous sunspot cluster lingers on the solar disk. It's notably silent despite its size, a sprawling dark patch visible even through amateur solar telescopes. Yet, it has not produced significant flares. It is as if holding back a reservoir of energy it's not yet ready to unleash, a loaded gun with an uncertain trigger. The overall sunspot count remains high and stable, signaling the sun is in a state of sustained volatility, not just a momentary spike. This quiet giant is about to rotate to the far side, where it could evolve in secrecy, its magnetic fields tangling and reorganizing away from our prying eyes, before possibly returning in late December or early January in a far more explosive mood. Some analysts speculate it may be gathering strength for a historic event within this solar cycle, an X-class flare of unprecedented magnitude directed at Earth. Only time will reveal the truth, as solar prediction remains a challenging frontier of heliophysics. Back to the imminent event, the coronal mass ejection from that major flare is now approaching, riding alongside a stream of faster solar wind from a coronal hole, potentially creating a compounded impact. This leads to a compelling question that resonates beyond mere observation. Is this series of eruptions part of a grander, hidden pattern of energy release we don't yet comprehend, or simply the random pulse of a star? Does the sun have its own rhythms and cascades that our models fail to capture? Or are we witnessing stochasticity, the inherent randomness of a chaotic magnetic system? This question lies at the heart of modern space weather research. The most startling element of the past 48 hours is that eerie timing. The flash of the solar flare in the X-ray spectrum and the jolt of the Alaskan quake occurred in a temporal window that feels too close for mere chance, a coincidence that prickles the neck of any observer. This prompts a profound mystery that has haunted scientists and philosophers for centuries. Could immense forces on the sun directly stir activity deep within the Earth, or is this a cosmic coincidence in a universe filled with them? The mechanisms for such a connection are not well established in mainstream geophysics, but hypotheses exist, ranging from the subtle pressure of the solar wind on tectonic plates to electromagnetic induction in the planet's conductive mantle. Some alternate theories suggest these events signal a shift in our planet's protective magnetic field or the onset of natural cycles humanity hasn't previously encountered, pointing to historical correlations between solar minima and seismic activity. Let's examine the seismic data closely. Moving from cosmic speculation to terrestrial fact, the USGS map shows that magnitude 7.0 quake, the largest global event since October, an unmistakable spike on the planet's seismic record. What makes this sequence abnormal is the relentless aftershock swarm, a density and persistence that stands out. In just one day, the area recorded 152 subsequent tremors, a statistic that conveys relentless activity. The largest was the main quake, and while a bigger foreshock is statistically possible, models give it less than a 1% chance, indicating this was almost certainly the principal energy release. The Earth's behavior here is defying typical patterns, presenting a sequence that invites closer scrutiny from seismologists worldwide. Notably, just weeks prior, a magnitude 6.0 quake hit near Anchorage but produced very few aftershocks, as if stress was building quietly, not fully relieved by that event. Now, a much larger quake has struck in the same broad tectonic zone, the Pacific Plate, subducting beneath the North American Plate. This hints that a large-scale stress change may be migrating through the entire region's geological framework, a transfer of load along complex fault systems that we are only beginning to model with precision. It suggests the crust in this region is in a highly sensitive state, responding to both internal forces and, perhaps, external triggers. The strength of these aftershocks is also unusual, demanding attention. We've seen magnitudes above 5.0, which are significant events in their own right. Normally, the strongest aftershocks are about 1 magnitude unit lower than the main shock. Here, the aftershocks have been densely packed, with magnitudes clustering around 4.0, creating a near-constant sequence of shaking that has frayed nerves and fascinated scientists. Residents report feeling a persistent, low hum from the ground, an unsettling and ominous sensation that speaks to the continuous release of seismic energy, a planet groaning as it adjusts. All this points to a colossal release of the Earth's pent-up energy, aligning with independent forecasts made for increased global seismic activity during this period based on planetary alignments and tidal forces. And that brings us back to the tantalizing solar connection, the thread that ties the heavens to the Earth. Around the time of the quake, the planet's electromagnetic heartbeat, the Schumann resonance, recorded a significant and unusual spike, a burst of power in the extremely low frequency range. This burst of energy did not correlate with any major global lightning activity, suggesting its source may be from beyond our atmosphere. Could it be a ripple effect from the solar flare, a direct injection of energy into the Earth ionosphere cavity, or evidence of a deeper cosmic energy exchange we're only beginning to detect, where solar particles influence atmospheric electricity, which in turn couples with the geologically stressed crust? The pathways are speculative but intensely studied. The simultaneous occurrence of a solar storm, a strange Schumann resonance pulse, and a major earthquake creates a narrative that is both scientific and deeply mysterious. It forces us to ask a fundamental question about our place in the cosmos. Is our planet entering a phase of heightened sensitivity to forces from space, Or is this the opening act of a larger energetic drama about to unfold as the solar cycle progresses? Are we seeing the first signs of a more integrated system physics, where the traditional boundaries between astronomy, geophysics, and atmospheric science blur? A ground motion visualization of the Alaska quake shows energy waves radiating outward across the continent like ripples from a stone thrown into a pond. Red indicates upward motion, blue downward, capturing the vertical shift recorded by a vast network of sensitive seismometers. While most in the continental US couldn't feel it, the instruments did, a testament to our ability to monitor the planet's faintest tremors. The energy traveled across the entire northern hemisphere, a reminder of our planet's incredible capacity to transmit force globally through its rigid crust and malleter mantle, ringing like a bell struck by a massive hammer. Now, an intriguing geographical footnote emerges, one that blends science with a sense of wonder. When you plot the quake's epicenter on a world map, you find it rests almost perfectly equidistant from several iconic ancient sites: the pyramids of Giza, the Nazca Lines, and the Angkor Wat complex. Drawing a circle creates a curious symmetry that is geometrically striking. Ancient stones, modern tremors, a coincidence that sparks the imagination. Is there meaning there? Archaeologists and historians would dismiss any direct causal link, and rightly so. It's likely a random alignment in a world full of points and lines, but it's a fascinating intersection of modern science and ancient wonder that invites curiosity about how past civilizations might have perceived such synchronous events, attributing them to gods or cosmic forces. Turning back to space for a definitive forecast, NOAA's model clearly shows the CME's trajectory aimed squarely at Earth. From a top-down view, the path is direct, a bullseye plotted across the inner solar system. Switching to a side perspective confirms it's a near head-on impact, not a glancing blow. While it originated in the sun's northern hemisphere, it's angled to deliver a potent blow to our magnetosphere, maximizing the transfer of energy. The data suggests high speed and density, a combination that often leads to stronger geomagnetic effects. The official forecast calls for a G3, or strong geomagnetic storm, with the noted potential for periods reaching the G4, or severe threshold. This sets the stage for spectacular auroras, the visible manifestation of this invisible collision. The influx of charged particles, channeled by Earth's magnetic field toward the poles, will excite oxygen and nitrogen molecules in the upper atmosphere, causing them to emit photons of green, red, and purple light. The auroral oval, the ring of activity around the magnetic poles, is expected to dip deep into mid-latitudes. For the nights ahead, the viewing band could stretch across the northern US, from Washington state to New York, and deep into Europe, potentially visible from Scotland, Scandinavia, and even northern Germany. If the storm intensifies to G4 levels, sightings could reach even further south, perhaps surprising viewers in places like Oregon, Illinois, or the Netherlands. Your best chance is to find dark skies, far from city lights, look north, and use a camera with a long exposure to capture colors often faint to the naked eye. The peak is expected in the coming hours, though timing may shift by a few hours based on the final speed of the solar material. This same storm will also light up skies in the southern hemisphere. Places like New Zealand, Tasmania, and the southern tip of South America may catch a stunning display of the southern lights, or Aurora Australis. This global phenomenon underscores that the impact is planetary, a shared experience for people under both polar skies. Beyond the immediate light show, it's worth considering the broader context. Solar storms of this magnitude serve as a stress test for our technological civilization. They can induce geomagnetically induced currents, GICs, in long-distance power lines, potentially triggering voltage instability or even transformer damage. Satellite operators may notice increased drag on low Earth orbit craft and take precautions with sensitive electronics. High-frequency radio communications in polar regions can be disrupted. While this event is not expected to cause catastrophic infrastructure failure, it is a live exercise, a reminder of our vulnerability to the sun's moods and the importance of robust space weather forecasting. Furthermore, the biological and psychological effects of such intense geomagnetic activity are a growing field of study. Some research suggests correlations between geomagnetic storms and changes in human neurophysiology, sleep patterns, and even collective mood. While far from conclusive, it opens a door to the possibility that we are not just passive observers of space weather, but potentially subtly influenced by it, connected through the very magnetic fields that shield us. Looking back in history, we find echoes of today's event in much larger extremes. The Carrington event of 1859, a solar superstorm, caused telegraph systems worldwide to fail, with operators reporting sparks and fires. Auroras were seen as far south as the Caribbean. In our far more technologically dependent age, a similar event would be catastrophic. Today's G3, G4 storm is a gentle whisper compared to that historical shout. But it's part of the same solar language, a reminder of the power available to our star. As we monitor the incoming data from spacecraft like ACE and DSCOVR at the Lagrange point, providing us with a precious one-hour warning of the solar wind's exact characteristics, we are engaging in a form of real-time cosmic diplomacy. We are reading the sun's signals and preparing our systems, a testament to human ingenuity in the face of natural forces. These are the moments that remind us we live on a dynamic planet within an active solar system, a pale blue dot subject to the flows of energy from its life-giving star. This event is not an anomaly but an expression of the system's normal, vibrant function. If you want to stay updated on Earth's incredible story, from seismic shifts and volcanic awakenings to solar fury and celestial events, make sure you subscribe to Winds of Thought. We are here to narrate this ongoing saga, to bring you the science, the mystery, and the awe. If this journey through today's cosmic events resonated with you, please support the channel by liking this video. It truly helps us grow and continue providing this synthesis of information and perspective. For everyone in the Aurora Zone, we wish you clear skies and breathtaking views. May you witness the dancing curtains of light, a direct visual connection to the storm raging in the space around our world. Thank you for watching, and we'll see you in the next update, as the sun continues its eternal and influential dance.